Okay, let's see if I can get rid of that for you. All right, Josh, here we go. So your own YouTube video for you. So here we are, we're reviewing for Chem Test B. And what we're looking at is the three phases of matter, which are solid, liquid, and gas. And what do all these have to do with each other? Well, essentially, they're all made out of atoms. And in a solid, the atoms are barely moving. They're packed tightly together. And that's what makes something solid. So here are all the atoms in the solid, and they're just kind of shaking back and forth. Right? Next up, liquid. Atoms are a little farther apart. They kind of bump into each other. And you can imagine these all moving about. Okay, a little faster. And then in a gas, they are very far apart. And they are zooming in all over the place. Let's see if I can find this simulation for you. Yeah, we're just going to replay. So here they are, solid, liquid, gas. You can see the temperatures changing here. Gas, far apart. All right, let's put that away. So, when a solid turns to a liquid, we call that melting. Let's make that a little smaller. Okay. When a liquid turns to a gas, call that boiling. The gas turns back to a liquid, we call that condensation. And when a liquid turns to a solid, call that freezing. All right. Shoot. Put some weight on that thing for you. Well, I'm not going to worry about that. But anyways, solid to liquid is melting. Liquid to gas is boiling. Gas back to liquid is condensation. Liquid to solid is freezing. So going this way, going down, that's increasing energy. And going from gas to solid, that's decreasing energy. Okay, let's go over to this one. When we are measuring gases, we're usually measuring one of three things: pressure, volume, and temperature. All right, and then these three things if one of them changes, the other two often will change. So if we change the pressure, it might cause one of these two to change. If we change the volume, it might cause one of those two to change, and temperature. Pressure is normally measured in atmospheres. A little bit smaller. Can be measured in torr. So there's different ways that we can measure atmosphere. And the way that we usually do in our book is kilopascals, K meaning 1,000. Volume, almost always measured in liters or milliliters. would be 1,000. 1,000 milliliters, 1 liter. And temperature, remember, is measured in Kelvin. And to find the temperature in Kelvin, you take your temperature in degrees C, and then you subtract 273, and that'll equal your temperature in Kelvin. So for example, right now in the classroom, it's 20 degrees C. Oops, let's change that to an addition, thank you. It's 20 degrees C plus 273 equals 293 K. All right, so let's look at the relationship between these really quickly. If the pressure goes up, what happens to the volume? Well, let's write this in a little chart. So if P goes up, sorry about that. If P goes up, you can do it. I know you can. Let's try that again. If P goes up, and what does goes up? Darn it. Let's try that again. Temperature goes up. And volume. And that should make sense. If you squeeze something, it gets smaller. Okay. Okay, let's take volume. If volume goes up, what's the temperature do? Goes down. And pressure goes down. Finally, let's take temperature. Temperature goes up. Just like before. Oops. Why is that tool there? Sorry about that. Wow. Pressure goes up. What's the volume do? Think about it. It goes up also. All right. So that's the basics. Now, of course, it's chemistry. So they want us to do some calculations. All right. And then we have these basic formulas. P1 V1 equals P2 V2. And I'll show you an example of that. And let's just do one more. Let's do one with temperature and pressure. And these we're going to be dividing. Pressure 1 over temperature 1 equals pressure 2 over T2. So let's give an example for each of these. Okay. Move that out of the way. So let's say that we have a balloon. Make it a pink balloon. Okay. And let's just say that the pressure equals 101 kPa. And the volume equals, we'll make this simple, 1 liter. And then what I do is I do something. I'm going to increase the pressure on this balloon. I'm going to squeeze down on it, so now the volume is only half. Now, what's our new volume? I don't know if I said that right. So again, here we have a pressure of a balloon. It's 101 kPa. And here what I've done is I've actually reduced the pressure. The pressure went down. What's the volume going to do? Well, let's just figure this out mathematically. We want to know what's V2 equal to. We know what P1 and V1 are. They're over here. We know what P2 is. We need to solve for V2. So here's V2 over here. We want to get this P2 over on this side. Remember in algebra, if we have something over here multiplied, we want to get to this side, we put it below. Okay, so our new formula is going to be P1 times V1 divided by, oops, try that again, divided by P2. And then we can do the math. I'm going to pause quickly. All right, so here's our calculator. So we have 101, which is our P1, times 1, which is 1. All right. I'm going to divide that by 50.5, which is our P2. And we get 2. So get rid of that. Sorry about that. So over here equals 2. 2 what? 2 liters. Okay. Let's go down here. Let's solve another one. Let's say this time we have a can of soda, black soda. Let's say that the, wow, sorry about that. Let's say the pressure right now is equal to 23 kPa. The volume is 354 milliliters. And, oops, temperature, sorry, temperature, doing pressure and temperature, equals 273 K, so it's frozen. And now what we're going to do is we're going to put this in a car. And we're going to make the temperature go up by 100 degrees Celsius. It's boiling. Okay, what's the new pressure going to be? Okay, please pause while I get the calculator. Okay, so we want to know what P2 is. Okay, with this T2 has to get the other side. Remember, now it's on the bottom, now it's going to be on the top. So our new formula, wow, our new formula for P2 is going to equal T2 P1 divided by T1. So let's get our calculator out. T2 is 373. Pressure 1 is 23 kPa. Then we're going to divide that by our old temperature, 273. Now we get a new, wow, let's try that again, 36.2. Equals 36.2 what? kPa. All right, that's it for that. And I'm going to give you one more question using the ideal gas law.